Before we complete today's notes, I would like for you to pause the video, complete the warm-up, and then check your answers when you're done. I said pause the video. Pause it. All right, here are the answers for these three problems. Obviously, you could pause the screen right now and check the work that you did, and please email me with any questions. Today, we're going to look at de Moivre's theorem. De Moivre was a famous mathematician from France, and apparently he was really good friends with Sir Isaac Newton. They probably did not Snapchat each other, but I'm sure they were tweeting. I don't know. That was lame. Okay, so anyway, what did de Moivre do? De Moivre created this formula where if you have a number and it has to be in trig form, so anything that's not, you would have to convert, and it's raised to a power, it's equivalent to taking the r value and raising it to that power, but then taking the angle and multiplying it by that value. So where does this come from? Well, if you think about what we've been doing recently with, 2 cos theta, and if I said multiply that by 2 cos theta, and actually let me even fill in angles here. So let's just say I said 30 and then I said 30 here. From the problems up above, you would see that when you're multiplying two values together in trig form, remember we talked about multiplying the numbers in front but adding the angles? Well, notice here, if I were to do that, I would multiply the numbers in front, which is actually equivalent to 2 squared, and then I would add the angles, 30 plus 30, which is really 2 times 30. Well, think about if I had another one of these, 2 cos 30. Wouldn't I multiply all the numbers in front, thus giving me 2 to the third power? And then I would add 30 plus 30 plus 30, and that would give me 90, or 3 times 30. You can see how this works using the property we just learned about yesterday. So it does make sense that we could use this. Just kidding. Anyway, so looking at problem number 4, if we're going to use this formula, this theorem from de Moivre, we're going to take 2 and raise it to the 5th power, and then we're going to take this 27 and we are going to multiply it by 5. So 2 to the 5th power is 32, and then cos, and then this is going to be 5 carry the 3, 135 degrees. Now, depending on how they want you to write the problems, in this case, they want you to write them in standard form. Remember that this is trig form. So what we're going to have to do now is find the cosine and sine of 135 degrees, which if you recall is going to be right here in the middle. So I can rewrite this as 32, and then I can multiply that by the cosine of 135 plus I sine of 135. Cosine of 135 is going to be the negative root 2 over 2. The sine of 135 is going to be the positive root 2 over 2. So what I end up getting when I distribute that 32 is negative 16 root 2 plus 16 root 2i. So again, that would be equivalent to taking 2 cos 27, writing it out 5 total times, and then multiplying those all together. For the next problem, same idea. If you want to pause the video right now and try this one out on your own, just don't forget to write it in standard form. So here's the work for number 5. You're going to do 5 to the 4th power, cos, and then 150 times the 4. 5 to the 4th power, I believe we get 625 there, cos, and then the 150 times the 4 is what, 600? I should have my calculator out because I'm putting myself on the spot right now, and we know how well that goes. And then from here, we can get this in standard form. Now, unfortunately, 600 is not directly on the unit circle, but remember we have this idea of coterminal, that we can subtract 360 and get 240. So we can use 240. So this is actually equivalent to this. You're going to get the same exact answer. So what we can do then is go to our unit circle and find the cosine of 240, and 240. And then from there, we can evaluate this. So 240 is right here, which means my cosine is negative 1/2. And then my sine is negative root 3 over 2. This is not going to be a nice value. So if you want, you can divide it out, or you can leave it as an improper fraction. So let's see what that decimal is. I probably could do this in my head, but I could be wrong when I get it. So we're just going to take the safe route. And then we're going to see that same thing here with a minus 312.5 with a root 3 and then I in that answer. Problem, we get to number 6 and we have an issue here. If you look at number 6, I can't distribute this power of 4 because there's a sum here. And remember that that is not allowed. Now, what I could do if I had a lot of time, which I'm sure a lot of us will in these next couple weeks, I know that that is not a joke and that's not something to laugh at. But I just feel like after a week with my kids, we're all getting to that point where we need to go back to school. But anyway, so with this one, you could, mathematically speaking, write this out 4 times and multiply these all together. Blah, 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 blah. That was just 2. And then multiply them, get your answer from there. But our homeboy, Demov, showed us this formula that allows us to escape that process and save us tons of time. I mean, imagine for number 7, when that value is a 12, you don't want to do that 12 total times. So we're going to have to use his formula, but the problem is this is not in trig form. This is standard form, right? We have the a plus bi. So if we are going to do this problem, we have to get it in trig form. And very fortunately, I gave you guys question number 1 in the warm-up. And question number 1 was this problem, and you were asked to write it in trig form. I wanted you guys to see that process before we did it, along with what we just learned with Demov's. So notice that we got this 8 kiss 5 pi over 6. So what we can do is we can rewrite what's in the parentheses as 8 kiss 5 pi over 6. And then the 4th power on the outside. See ya. Oh, I'm going to need it back. What a waste of energy there. So we're going to have to do this 8 to the 4th power, which I do not know offhand. So 4,096. And then we're going to take this 5 pi over 6 and multiply it by 4. You know, as you do these problems, you are allowed to work with either radians or degrees. Obviously, the way the problem's given to you, you have been working with, for example, this one, radians. But if you go back to this one, you could have easily told me that that theta was 150 degrees. A lot of people, when using Demov's theorem, like to stay with radians because the numbers are smaller. So notice this is math I can do without a calculator here. We can cross cancel, or if you just want to multiply across, I know both of these are divisible by 2. Now I feel a lot of pressure to get this right since I just said, no, I could do this without a calculator. And you should get this 10 pi over 3. Now, directions are still the same. We want to write this in standard form. So to write this in standard form, I don't know where 10 pi over 3 is on the unit circle, but I do know I can subtract 2 pi, which is equivalent to 6 pi over 3. So I get 4 pi over 3. So we're going to use that instead. I was about to put the calculator away, but then I realized, wait, maybe I should, hold on. 4 pi over 3. And then plus I sine 4 pi over 3. So going to 4 pi over 3 on your unit circle, we are going to be right here. And so then from there, we can rewrite this cosine 4 pi over 3 as negative 1/2, negative root 3 over 2. And then we can multiply 4096. We actually could divide it by 2 or multiply by half, same thing, and get this negative 2048. And then same thing with, okay, I guess it's staying, minus 2048 root 3 with an I. And voila. Final problem in the set, and then I'm going to have you guys try 2 and then check your answers with the next video. Or you can even check the key, and I will post a video just to help those of you that are struggling with this topic for the work for those. With number 7, wowzers, same situation as number 6. We cannot just distribute the exponent. We have to get this in trig form first. So in order to do that, think about the work on the warm-up. You need to start by graphing this and thinking about 1 minus I. So I'm going positive 1, but then down 1. Now, to find your R value, remember R squared. We're going to use that Pythagorean theorem. So I'm going to get 2, and then R being the square root of 2. And then to find theta, definitely going to use tangent here. Tangent theta equals negative 1 divided by 1. Remember that you are in quadrant 4 here. So you need to give me a theta that's in quadrant 4 that has a ratio of negative 1. Well, that has to be the middle angle in quadrant 4. So I'm going to go 7 pi over 4. Again, you can go radians or degrees on this. Now, we haven't even done de Moivre's theorem, and that's actually a common mistake, is that people will then get this answer, this root 2 kiss 7 pi over 4, but then they'll forget to raise it to the 12th power, so we haven't actually done our work yet. Now, to start, we're going to take this root 2 and raise it to the 12th power, but that looks scary. Remember that square root of 2 is just 2 to the 1/2 power. So if we were to multiply the 1/2 by the 12, this is really going to be 2 to the 6th power. And then kiss, and then we get this 7 pi over 4 times 12. And again, that's why I use radians. Look how easy this is to multiply this then, because that's going to cancel, and we're going to get 21 pi. Now, to convert this in standard form, well, think about multiples of 2 pi. 2 pi times 10 is 20 pi, and this is one more than that. So this is really equivalent to, you can think of it this way, 21 pi minus 2 pi times 10. It's really going to give us pi. 21 pi, if you go 21 pi units around, you're going to land at pi. So this is really equivalent to 2 to the 6th power kiss, and then pi, as I just said. Now, 2 to the 6th power, 2 to the 5th power is 32, so times another 2 is 64. And then we can do cosine pi plus I sine pi. So cosine pi is equal to negative 1, I sine pi is equal to 0. So when I distribute, I just get the negative 64. And that is the final answer for this problem. So what I would like for you guys to do at this time is try problems 8 and 9. You can check with the key, or I will post an additional video with the work, me working through each of those just to show you, if you are struggling, what to do.